So welcome to my dear my dear students. So today we are going to discuss in very brief the simulation. Say there is a pipeline, and in between there is some pump. That pump is pumping some water from one elevation to another elevation. So suddenly if the pump is tripped, then what kind of pressure fluctuation or pressure transient may occur in the pipeline, that we are going to understand. So already this course this from Indian Institute of Science and Technology, my student Shoham is doing this course. So I am just showing this simulation is in within a very short time, but in the next video Shoham will explain in details. Okay, so I am opening that. Already you can see my other videos. So first we will consider the steady state. So here simply I took one pipeline and with a pump. So this is a reservoir. So this head is 5 meter. Naturally this pipeline also, and this video is not for the beginners. Already who are in my earlier videos, you can see in my channel. So there this how to do all these things, what are the interface, how to fit the parameter, all these things are given. So this segment, it is the elevation is 5 meter. Now I am going for a pump. So it's a centrifugal pump. So in the centrifugal pump I am selecting this as the discharge head efficiency table. QHE means discharge head and efficiency table. So this is the table. Arbitrarily I taken some of our raw and service water pump characteristics. So you have to feed the discharge head and efficiency. Automatically power it will be calculated. And this pump is connected with a 6-pole machine. The 4-pole machine. So it is the rated speed is 1500. Okay, and here this segment, the elevation I am using as 5 meter, and this is a pipeline. So this is a 200 NB, and the wall thickness, wall roughness will be around 1 millimeter, and the length is 5 meter. And this segment also elevation is 5. Now I am using a check valve. So that dia is 250, and the loss coefficient it's given as 1. Arbitrarily I given. Now I am using two pipe. So this pipe, the geometry is given here. This is the profile, that also arbitrarily I given. So at 0 distance it is 5, and it is at 600 meter the elevation is 15. Just I am creating one arbitrary profile to understand the surge. So as the elevation started at from 5, so this also it is 5, and these things it will, if you see, this will end as 15. So this I have given arbitrarily 12, because if you see this profile, okay, if you see this profile, this is started from 12, so that's why this part is given 12. So this is the arbitrary profile it is given, and it is the 400 NB pipe. If you see the profile, its height started at 12 meter, so that's why it is given, and ending at 40 because this reservoir is at 40 meter elevation. So normally if the pump, and normally this segment also it will be 40. So what will happen if this pump is suddenly tripped? So what will happen? There will be backflow, and there is a check valve. So normally in this portion some transient will occur, but this portion is for the steady state. I am showing the steady state. Now if you see and do the steady state calculation, and if you see this, the head, the total head in this pipeline, you can see this kind of thing. It's a steady state. Normally based on the profile you can understand the what profile I have selected. Based on that profile the head is varying, even though there is a discontinuity here. This is due to, as I am taking arbitrarily, so this kind of discontinuity is coming. Need not to worry, just I am giving you one idea. Okay, this is the steady state situation. Now I am going for the transient situation. That means suddenly I am going to trip the pump. So for that, let us open transient model. So normally, you know, in model option I have here selected in the, sorry, not this one, so this is my transient model. So normally in transient calculation, if you select the mode, here I have selected the transient mode, and in time parameter settings I am selecting the time step as 0.1 and the simulation time is 200. So if you select that one, then in the pump, what I did here, I add some extra parameter during the transient study. This is the GD square value, because once the power supply failed, so immediately pump will not come to zero speed. Due to moment of inertia, it will rotate sometime. So to avoid this transient, you have to, if you increase the GD square value of the impeller by adding some flywheel or something like that, then you can avoid it. Okay, then I am selecting the pump as a trip, and within 2 seconds the pump will trip. This option I have selected, and this pipe I have selected instead of water hammering, because you have to give the exact wave speed, you know, in my earlier video. So here I have selected the rigid column. I am assuming it. Okay, and likewise earlier I have given here the specified wave speed of 1200 meter per second, and this also 1200 meter per second wave speed is given. Now let us calculate the transient. So now if you see here the total head, now you can see what is happening here. The pressure is started to fluctuate, and you see the head of the two reservoir was just like, one is 5 meter, another is 40 meter, and you see now the pressure is going from 5 to 85 and it is keep on fluctuating. So this kind of transient may occur once the pump is getting tripped. So this only I was just going to give you a glimpse. So I would like to, I am requesting Soham that the same thing, you can take some more practical data available, some pump data sheet you can download from the internet, and you can create some more appropriate, because I am just giving you the idea how to do it. So you can take that and you can simulate in a better way. And while you will be simulating it, just take Diya and Shouvik in line so that they can also learn it. So you do that. This is your assignment. You do it, and as earlier, you record the video and send it to me so that I can put in my channel for the other student or the student who will be doing the course in future. It will be helpful for them. Thank you so much. Thanks for your patience.